So we'll have the pointer on here. There we go. You need the derivative of this product. So start with one of them plain and then times the derivative of the other plus and then alternate it. The derivative or the plain version of the second one times the derivative of the first. Derivative here is 2. Derivative there is 6x minus 5. And from there it's just a simple simplification problem. So when you multiply out here and here, this is what you get. And combine like terms. There, and then you have an x term, x term, x term to get this. And then the minus 25 at the end. There's one little mistake there. It should be a plus at this point, a plus 10x. The quotient rule, you're going to start with the denominator, plain, times the derivative of the top term, and then it's going to be minus the top term, plain, times the derivative of the denominator, and then on the bottom you square it. And from there it's a simplification problem there on down. You can leave this as a quantity squared unless it results in a cancellation. On number 3 you have the chain rule. You need the derivative of the item under the radical sign on the top, and on the bottom you need that radical item and then multiply it by 2. The 2 does not come from the problem, the 2 comes from the actual rule, so it appears in all of the answers for at least a time. And then your derivative on the top, and down here you're still going to need to simplify from that point. You can't leave a radical term on the bottom, so you would multiply the top and the bottom by that term, and it cancels out the signs down here, and you're left with this. On one of these problems I went ahead and multiplied through by 2, and this one I did not. I would prefer that you multiply through by 2. Maybe that's the problem I was thinking about, and it was something different. On the top, there's not much you can do with this. You can leave it the way it is, and then on the bottom just multiply through by 2. Well, number 4, it's a product rule, so you can, since it's a sum in the formula, you can start however you want. You can do first term times derivative of the second, and then add to that second term times derivative of the first. Find the derivatives and multiply from there on out. And you end up with this long expression which you must simplify by adding like terms, and you should get 6x squared plus 14x. Yeah, just a small mistake there. You have need my marker. There it is. Have a 4x, and a 2x. That should be a 10x. 6x squared plus 10x. Well, this will be a quotient rule. So you start with the denominator times the derivative of the top, and then subtract the top times the derivative of the denominator and square the denominator. Find your derivatives there, and then multiply where you have to come up with this. The bottom is squared. And here's a common mistake. Not realizing that all of this back here is just going to be one quantity, and you have a minus sign. So keep that minus sign, do your operations here and enclose it in parentheses, and then go back and distribute the minus 1 to each of those inside. And of course simplify like terms, and you can leave the bottom as a quantity squared. Ellie found another mistake, and I'm recording that as well. This right here, the derivative should be just 10x. So I've put a square in there by mistake, which means this is going to get knocked out at some point here. This is just going to be 10x times 2x, which is 20x squared. So this one would get wiped out and be a 2. And does that satisfy the rest of those? And this one is just going to be simply 10x. So that does alter it a little bit there. This one out here would still be okay at that point. So we can go back through and look at it as 20x squared right there, and then plus 6x minus 10x. So that one would go away. And you would have 20x squared minus 10x squared, so you should just have 10x squared. And then 6x minus 10x is a negative 4x, minus 6x is a negative 14x, and then your minus 3 stays. You have 2x minus 1 quantity squared. So this one is the chain rule. You need the derivative of the item underneath the radical sign, and then your radical item on the bottom times 2. The derivative of the top is 8x minus 3, and then multiply the top and the bottom by this entire term, and it's going to cancel out the radical sign on the bottom, leaving you with that, which you should multiply through by 2 on. And then the top, there's not much you can do with that. You can leave it as a product. And this is just a product rule problem, pretty straightforward. Comes down to be that. That's a quotient rule, so you have the bottom times the derivative of the top minus the top times the derivative of the bottom. Your derivative here is 6, and for this one it's 4x plus 3, so just multiply out. Don't forget to square the bottom. And then you're going to have the denominator missing from the rest of the problem, which is kind of strange, but I just left it out. So you need to insert that denominator here and square, and the same thing on this one. 2x squared minus 3x quantity squared, and another time 2x squared minus 3x quantity squared. And of course it does help if it shows up in the final answer as well. If I can slip that in there, there we go. 2x squared minus 3x, and then quantity squared. Number 9 is a chain rule. So you need the derivative of the item under the radical sign over the radical term times 2, and this derivative is 12x squared minus 5. Multiply the top and the bottom by the radical term to cancel out the sign, and you're left with this, which you should multiply by 2, and on the top you can leave that as a product. Well, this one is just a simple product rule. This shouldn't be too rough. It's this one times the derivative of this one, and then plus the second one times the derivative of the first. Derivative here is 2x plus 4, and then derivative there is 12x to the third. Multiply where you have to and simplify like terms. 18x to the fifth plus 60x to the fourth. Here's an example of the chain rule. You need the derivative of the item under the radical sign. So derivative with respect to x of 5, x squared minus 3x plus 2, and then on the bottom you'll need a 2, and that's part of the formula. The 2 comes from the formula, and then you'll need the radical term, square root of 5x squared minus 3x plus 2. So on the top, that derivative is 10x minus 3. And on the bottom, you have 2 times the square root of 5x squared minus 3x plus 2. And to simplify that, you multiply the top and the bottom by the square root of 5x squared minus 3x plus 2. Now on the top you'll have this, and you need to put it in parentheses, and then this. On the bottom you'll have 2 times just that item under the radical sign. So you can go ahead and multiply it to get 10x squared minus 6x plus 4. This is an example of the quotient rule, and it starts off with the bottom times the derivative of the top, and then subtract the top times the derivative of the bottom. Running out of space. I think I can get it in there. And of course the bottom is going to be x plus 4 quantity squared. So next you need the derivative of your items that you're finding the derivative of. So x plus 4. The derivative of 2x minus 3 is simply 2. Keep this quantity the same, and the derivative of x plus 4 is 1. So on the bottom, this one stays the same. Now multiply to get 2x plus 8. Now notice this is minus, and since you're multiplying by 1 at the end, it's just canceled out. So that's minus 2x plus 3. And then x plus 4 quantity squared. On the top, 2x minus 2x is gone. And then 8 minus 3. Well, actually not 8 minus 3, but it's 8 plus 3, which should be 11. And then on the bottom, x plus 4 quantity squared.